Hello everyone. Today I'm going to talk about a squeeze principle. This principle is generally used when the other algebraic simplifications cannot be effective in solving limits, and then we have to use this principle. In general, for using this principle, we have to look at three different functions, and three different functions should exist there. Basically, we should make those three functions in order to find the final solution based on this principle. Let's look at this principle. Suppose that we have three functions like f, g, and h, which satisfy the following condition as g of x is equal or less than f of x, and f of x is less than or equal to h of x. And we know that for this function, the limit of g of x when x is approaching to a is equal to L, and the limit of h of x when x is approaching to a is equal to L. Therefore, we can say the limit of the function which is in the middle of these two is equal to L when x is approaching to L. And we know that a can be a finite number, can be minus infinity or infinity. At the same time, L can be infinity, minus infinity, or a finite number. Let's look at one example and to see how we can use the squeeze principle for solving a limit. So here we have the limit of x squared sine 1 over x when x is approaching to 0. As you can see in here, the first rule that we can use for solving of this problem, and the first thing comes to mind, is multiplication. And basically we can write this limit in the form of the limit of x squared times the limit of sine 1 over x when x is approaching to 0. So if we plug in 0 in x squared, clearly the result is going to be 0. But we don't know what is the sine of 1 over x when x is approaching to 0. If we plug in 0 in there, we don't know what is the answer. But we know that the sine of x is a periodic function which is between 1 or minus 1. Therefore, we can say sine of 1 over x is actually between 1 and minus 1. So what we have to do in here, somehow we have to convert this equation, this inequality that we have written in here, in the form of the function that we have in the limit. The easiest way to do that is just multiply this actually form with x squared, and we can get x squared negative, which is less than x squared sine of 1 over x, which is less than x squared. This is exactly the form of, let's use another color. This is exactly the form of f of x, and then here we have h of x, and here we have g of x, for example. Now we can use the second part of the squeeze principle, and we can say, okay, the limit of this three different functions that we have in here is going to be, we can say the limit of minus x squared, which is g of x, when x is approaching to 0 is 0. The other term, which is x squared, and the limit of x squared when x is approaching to 0 is 0. We just need plug in 0 instead of x, and the answer is 0. Now let's look at the function in the middle, which is x squared times sine 1 over x, which is actually f of x. And based on the squeeze principle, we can easily say the limit of x squared sine 1 over x when x is approaching to 0 is going to be 0. So we use the squeeze principle. Somehow we looked to the function that we have in the problem, and we noticed, okay, this is sine of 1 over x. When we plug in 0 in that function, we cannot get an exact answer. But what we know about this equation, about this function, is it is a periodic function between -1 or 1. So the maximum value that it can have is 1, and the minimum value that it can have is -1. And using this actually property, we could move on with the solution procedure, and we could get the final answer. Thank you very much for watching this video. If you enjoyed, please subscribe our channel.